everyone, welcome back to my YouTube channel. My name is Noah. Today I'm going to show you how you can solve this problem. As you can see, this problem is question number 3 from Engineering Dynamics books, which is Mary 8th edition. So today we'll solve this problem. Before starting this problem, if you are new for educational too, make sure to subscribe our YouTube channel in order to access FA engineering problem solutions that are very important for engineering and other grade level students. Now let's jump into this problem and I will show every single step on it. So at a certain instant, the 18-pound crate has a velocity of 13 feet per second square up at a 20 degree incline. As you can see, this ramp is inclined at 20 degrees Celsius and this crate is moved in the S direction, which has 18-pound weight, so at a velocity of 13 feet per second square. And we can ask to determine the time required for the crate to come to rest, which means the final velocity is 0, and also determine the distance d, which means the distance d traveled by the crate speed when reduced to 15 feet per second. First it is 13 feet per second, which means then it is reduced in 15 feet per second. What is the distance in order to reduce this? And we are given here the coefficient of static and kinetic friction 0.4 and 0.25 respectively. We can simply use the condition of equilibrium and calculate the problem. As you can see, this is the free body diagram for this crate. In this direction you have weight times cos theta, and in this direction you have normal force, so the summation of force in y direction is equal to normal force minus weight times cos theta. In this direction you have weight times sin theta, and in this direction you have F force upper, which is the frictional force. So n is equal to weight times cos theta. Since summations of force is equal to, in the y direction is equal to 0, then n minus weight times cos theta is equal to 0. By rearranging this, you will get n is equal to weight times cos theta. It is very simple, so we can simply substitute the given value. The weight of the block is already known, which is some 18 pounds. Then we can convert into Newton in order to increase your visualization, and you can substitute the value theta, which is 20 degree, and you will get our normal force, which is 75.175 pounds. Then we can get summations of force in the x direction 0, which means force plus weight times sin theta, which are the same direction, and mass times acceleration. From it we can substitute the given value simply, and we will get the acceleration, which means coefficient of kinetic friction times normal force plus weight times sin theta, which is mass times acceleration. After substituting the given value here, we can get the acceleration, which is 18.5776 feet per second square. Okay, it is very important in order to calculate the times and the distance which is taken to the crater to reduce its speed from 30 feet per second to 15 feet per second. So next we will calculate the acceleration as equals, as you know, from uniformly accelerated motion. Acceleration is equals to the rate of change of velocity, which means acceleration is equals to v final minus v initial over time. From it we can rearrange this equation and we will get v final is equals to v initial plus 80, which is our v final is 0 because it's the come to rest at the final states, and we can simply substitute the given value here and we will get the time t, which is equals to 1.6149 seconds. So the time required for the crate to come to rest is 1.6419 seconds, and we can simply calculate the distance after this by using the equations of uniformly motion. As you know, uniform motion and uniformly accelerated motion are a very important concept in order to understand physics, or simply kinematics and dynamics. In the case of uniform motion, we have a constant speed and the acceleration is 0. In the case of uniformly accelerated motion, we have a constant acceleration, which means the speed vary at a constant rate. So we can use the speed of the equations of uniformly accelerated motions and solve different problem as you can see. So speed equals to initial times time plus 1 over 8 square, which means v final square minus v initial square is equals to 2as. We can simply substitute the given value here and we can get the distance, which is 24.22 feet. It is your final answer. It is very easy problem. If you have any question, you can put it in a comment section. Next we will do the next problem. If you like this video, make sure to subscribe our YouTube channel and share it for your friend. Until next time, I enjoy the rest of your time.